Okay, so today we're going to finish up our PowerPoint about thermochemistry. So thermo means heat and chemistry means chemistry. So thermochemistry is the study of heat changes in chemical reactions. So if you see that question on a quizzes or something, you'll know where it's coming from. So thermochemistry has to do with heat. So stuff we know already. Exothermic. Exothermic gives off heat. And if you remember that when we did a lab a long time ago, we had test tubes, and one of them got hot and one of them got cold. And that was the one that got hot was exothermic. Gives off heat, which you should know from your vocab list also. Now, let's take a look at the equation over here. Both of these, look where the energy is. The energy is coming out of the reaction. So it's coming out of the reaction, which means the energy is coming out, which is giving off energy. So something like fireworks, that is giving out energy. So here we have hydrogen plus oxygen makes water. That gives off a lot of energy, like the Hindenburg, which is what happened. On the other side of the coin, we have water and water, but this is water liquid going to water solid. That's odd. Water liquid to water solid. Now, that's when you take water, liquid water, and you put it in the freezer and it becomes a solid. The energy has to come out, and that's what the refrigerator and freezer does. It pulls that energy out. So the energy coming out is exothermic. So interesting. Freezing is exothermic. Now we'll talk about the other way in a second. You'll see. Now the other way is endothermic. Key words, nice vocabulary words. You should have got them right. Endothermic means it absorbs energy from the word endo. So good SAT practice when you guys take the SAT next year. So exo is heat out, endo is heat in. And look at where the energy is on this side. The energy is on the left side as compared to up here, it's on the right side. These are the reactants, these are the products. So look where it is on the reaction. The formulas are exactly the same, well, backwards, but look where the energy is. The energy is on the other side. So this one, you got to put energy in to break up water into hydrogen and oxygen. And here, you have to put energy in to ice to melt it, which makes sense. So you're putting energy in. Energy in is endothermic. And of course, another practical application is the hot pack, ice pack, which we kind of made little ones in test tubes and you guys saw already. Okay, so important things to know. Exo gives off, and look where the energy is. And then endo, heat goes in, and look where the energy is in the equation. These will be important. And of course, what would a PowerPoint be without a cat meme? Exothermic reactions, I studied them before they were cool. I know. Okay, so let's practice. If we know you're having a barbecue, you got a fire. Is that exothermic or endothermic? Drum roll. It's Aaron. What? Fire burning. Exo or endo? Oh. Were you not paying attention to my lecture? Exo. No. Okay, mommy was paying to the lecture, paying attention.
Why? Because it's hot like XXOO.
Oh, it's hot like XXOO.
Hugs and kisses.
Oh, well, okay then. That's a different way to remember it.
It
is a way to remember. I love memory mnemonic things. So I use the example exo meaning, and my wife's not going to like this, ex-girlfriends going out, out, away. You are now an ex. You have now been, you're out of the reaction. You're an ex.
No, my way is lovelier and more inclusive for these difficult times.
Okay,
in which we live.
so my wife likes the XXOO heat. Hot stuff, baby. Hot stuff. Okay. Now, of course, the opposite of hot, we have ice melting, which obviously feels cold, which is endo. So endo feels cold, exo feels hot, 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 hot. Okay, so now let's look at this cute little picture. Now, maybe you'll see it in physics, but this is a chemistry reaction. So let's take a look at what our coordinate is, though it's on our axis down here. We have the forward path, which means the reaction going. We have potential energy. Wait a minute, we talked about potential energy, and I'll have to give you the what during the week, so you can see what, and you can practice it at home when the weather is nicer, like on Sunday. So we have potential energy. Goes up. So look what we got here. We got something over here and something over here with the big bump in the middle. What the heck is that? Well, in this picture we have a car. The car is up on a hill. It's way in the mountains, but for it to get down to the bottom of the mountain, first it has to go over the little bump on the edge of the hill. So it's got to go up the hill a little bit more. That extra going over that little hump is called the activation energy. That's the energy needed to start the reaction. Some reactions need a little start to start a reaction, like barbecue. Barbecue is an exothermic reaction. It goes nicely. You'll see this is an exothermic in a little while. The barbecue goes, but it doesn't go by itself, thank goodness. There's no spontaneous combustion with your barbecue. You need lighter fluid and a match. That is the activation energy to get it started. But once you start your barbecue, you don't need to keep on putting energy in because it's giving energy out. So, what is that spark to get it over that hump? That's the activation energy. Okay, so this on this side are the reactants. This is the starting point where the reaction starts at 0. So this is the starting point. These are the reactants. This side is the product side. So look what's going here. This height difference from the bottom of the hill to the top of the hill, forget about the bump for now. Let's just look from here to here. It's going downhill. So if it's going downhill, that means something important as compared to going uphill. Okay, so we'll talk about that in a second. So here we have a car. You need activation energy to make it go over the hill. And we'll talk about catalysts later, that they affect the activation energy of reactions, but that's later. Okay, so we have our car. It wants to go down the hill. You got to start the car, got to push the car up the hill, put energy in, and then whoosh, the car goes all the way down to the bottom of the hill all by itself. Got it? Good. So, look, instead of a car going up a hill, it's chemicals. What chemicals? Here we have carbon plus oxygen. Here's our little barbecue going again. So we have carbon and oxygen. What we want to do is we want to give it some activation energy, put on some lighter fluid and a match. And what it does is that gives it enough energy to go up the hill. And then after it goes up this activation energy hill, it comes all the way down to the bottom. And it's giving off that energy. And what do you mean giving off energy? Look at this difference, amount of energy released. And this is from here to here. So this amount of energy is the energy of the reactants and the energy of the products. The thing that you're making is CO2. So you start off here, give it a jump start, and it goes down here. This reaction is also, just like the other one, going downhill. It's giving off energy, which obviously your barbecue does. So, what does that mean? Well, if you start from the top and you go down, but Mr. G, this is a straight line and not humpy like the other one. What's the activation energy is not there. This is the way it's supposed to be, but I just got rid of the activation energy because it might confuse you, because you might be thinking, you got to go up and then down. I'm confused. So just ignore the little bump now. All we're doing is we're doing from the start to the end. Start to the end. Okay, so doesn't matter if you stop at CVS on the way home. So start to the end. Start to the end. So there's no hump here. So the start to the end, you're going from the energy of the reactants to the energy of the product. It's going downhill. It's giving off that energy. That energy is coming out of the chemicals and turning into heat energy. So fireworks and fire, that is an exothermic reaction going down. So notice, start to finish, downhill. Just like riding a bike. You're at the top of the hill. There's no little mound at the end. You just go down to the bottom of the hill. Gives off energy. You don't need to hit that bicycle. Okay? So this is exo. The products have lower energy than the reactants, and energy is released. So it's exo. So if you see a chart that goes from top down, that is exo. And jeepers, wonder what the opposite is. Oh no, it's endo, which you start at the bottom of the hill, reactants, and you have to go uphill to give it more energy to ride that bicycle all the way up the hill. So you're putting all of that energy in. So by putting that energy in means endo. So you're putting energy in. If you're putting energy in, heat is being absorbed, and your products have higher energy than your reactants. You got to put energy in to get the bike up to the top of the hill. So it has more energy went in. Now you got to the top of the hill, you're all tired, and now you need a really good cold pack. Okay, so cold packs are endo, and ice is cold, so that's endo. Endo is heat absorbed. Okay, so jeepers, which beaker is endo and which one is exo? Well, the red and the blue might give you a hint, but don't always go by the colors. Look what's coming out. Energy is coming out. That must be, energy out is XXOO, exothermic. And here, look, the energy is going in, and it's endo. Energy out, exo, feels hot. Endo, energy in, feels cold. Okay, now we got two. Let's see if you know what's going on. Oh, and almost done. Okay, so here we are. We're going to go, oh no, this one's got a big hump again. This is that activation energy thing. You're right, it's there. For now, ignore it. For now. Okay, so reactants, products. So if I was doing this PowerPoint in front of you, I'd put my hand over this so you wouldn't be looking there, because we're only looking from reactants to products, from here down to here. Look, it's going down. Going down is giving off energy, which means it's, say it, Bueller, say it, going downhill is exothermic. And this one, look, you're putting energy in. But Mr. G, I have to put energy in and it comes back out. No. Ignore the bump. We're just going from the start to the finish. Reactants to products. Look, you have to go up the hill. Ignore the bump. Up the hill. This one is endo. You have to put energy in to get up the hill. Okay? So reactants, products. Don't worry about the little bumpy in the middle. For now. Okay? So you got it? Exo. This is exo. This is endo. Energy out, hot. Energy in, cold. Oh, delta H. Oh, that's that enthalpy thing you mentioned earlier. Yeah. Okay. Oh my goodness. Look at these questions. These look really complicated. Well, yeah, it should be. It's from an AP quiz, AP test. So let's take a look at it. Which are exo and which are endo? Well, let's see. This is really squiggly, Mr. G. I'm confused. Well, I'm confused by this. Don't even look at that. Who cares? Okay? So, we're looking from the start to the finish. Do we start from here? Do we start from here? How come it's not a flat line? I didn't draw it. It's the AP people trying to confuse you. So all we're doing is we're looking from the bottom part to the top part. So this one is going up, bottom, up. So that's endo, energy in. B, this one energy going downhill. That's exo. This one, bigger hump, but wait, we're still going uphill. So this one is endo. Even though it has a big hump, this height difference from the start to the finish is what you're looking for. So this one, energy in. This one still has a big hump, but look at the ends. Front, reactants, products, downhill. That one is exo. So now we have this one, energy in, endo, energy out, exo. Energy in, endo, energy out, exo. So now the question is, which one's the most exo? So which one has the most jump down? Well, we were just mentioning it before. From here way down to here, these two bottom ones, this one and this one, are the exos. So let's look. This one's got a long way downhill, and this one only has a little bit of downhill. Yes, it's got a bigger mountain in between, but look, the starting point and the ending point is close, and here the starting point and the ending point is farther away. The farther away, the bigger the energy. Didn't we just learn that in the last unit? With the farther they are on the activity series, the more volts you have. Oh, yeah, I think I remember that. Well, goodness, it's the same thing here, too. Look at that. Shocking. So it's nice to pay attention. Okay, so, and then which one's the most endo, most energy in? Well, this one's got to go way down here to way up here. And this one's got to go from down here to not that way up here. Yes, it's true. It's got a big hump in the middle, but we're just looking at the points in the front and the end. So this one is the most endo. Got it? Good, because that's the end. Now do your quizzes.